Okay. Okay, welcome everyone to the Sas Viya transition Q&A session. This is our very first Q&A session. So to view previous training sessions and to learn more information about upcoming events, the links listed there will take you to those spaces on the DNA portal, and then Laura is going to drop those in the chat as well, so you don't have to copy that giant URL. So before I kick things over to Tim, I'm going to go over just a couple of administrative items. So this meeting is being recorded. Please remember to stay muted to minimize interruptions throughout our meeting. The answer portion of this is going to be live, but the question portion is not. So we aren't having like a traditional Zoom chat where you'd ask the Q&A there. And I'm sure Tim's going to give you some more background information on that. But the questions that we have today are ones that have already been asked previously. So if you have a question that you would like to get answered, we are going to have a survey at the end of this session. And then that is where you can put that question, and we'll be sure to save that for a future Q&A session. So the notebook and any additional links, as I mentioned, will be shared in the Zoom chat. And then all meeting materials will be made available in the CCSQ DNA portal following the conclusion of this meeting. Just remember to give us a little bit of turnaround time there to make sure everything is 508 compliant and accessible. So with that, I'm going to go ahead and stop screen sharing and pass things over to Tim.
All right, thank you so much, Julia. Hi, everyone. My name's Tim. If you haven't seen me before, I am a senior data scientist on our user services team. This is my third live session in like a week and a half. So I think if you've attended all of them, you're probably getting pretty tired of me. But anyway, here we go with our first Q&A session. So first, a little bit of upkeep. What are we doing here? What is this session? So over the course of our interactive sessions, lunch and learns, office hours, basically every talk that we've given, you've asked us a lot of questions, and we have compiled them here. The questions that I'm going to go over are not your questions verbatim. I have taken the questions and condensed really similar ones and kind of expanded on questions that didn't have enough detail or where I thought that you might find useful things. So it's here, but like it's been expanded and condensed appropriately. As we said, this is not a live Q&A. The answers are going to be live. The questions are not. And the reason for that is because I don't want to be put on the spot trying to answer questions I don't know the answer to. So I will keep an eye on the chat if you do have like additional questions about the question that I'm currently answering. Depending on whether or not I can incorporate that new answer into this, I'll play it by ear. But generally, if you want to ask a totally new question, please answer our survey at the end of this call. So after all of our sessions, we send out a poll. There's a text box where you can type out your own questions. They go straight to us. So there is that. Also, don't forget that we have a help desk. So if you need like immediate help, please go to our help desk as well. People will, help you out with code there. So when submitting a question, also some guidelines. Please remember to be specific so that the person reading your question knows what you're trying to do enough to answer it. We unfortunately had to throw a lot of questions out that like didn't have any detail to them. So after reading them, like I just didn't quite know what the person was asking. So make sure to provide detail in your questions, including the language you'd like the answer in. I know we all love SQL, we all love Spark or Python, or we all love R, but sometimes a question doesn't have a language attached to it, and I just have to probably guess you are using Python, honestly. Also, please don't ask any questions regarding specific tables or data sets that you are working on, because I can't really talk about anything that has, PHI, PII, data that requires specific access. It's also very likely that I might not have access to specific data sets. So again, that might be a question that's more appropriate for our help desk. But other than that, fair game. I'm happy to help out with anything or answer it in our next Q&A session whenever we announce that. All right, so let's get started. Just a quick upfront about what questions I am going to be answering today. You asked about our old data camps, office hours, recordings, and notebooks and things like that. Some of them have become out of date. I'm going to talk about when, how, and why they will be updated. What are best practices for saving and reading data? to and from the workbench? And how can we use Databricks to explore the workbench? There was also a question about, are there any built-in references for zip codes, counties, states, things like that? The answer is yes. And how can we create window functions in PySpark? That was a really, really popular question. Everybody wants to know all about window functions in PySpark. I have your answers. And then finally, I want to talk a little bit about the Spark UI, kind of how to troubleshoot, know what a failed stage is or a skipped stage. Not super exhaustive, but we're going to talk about that a little bit as well. Okay, so the first question on our outdated materials. Databricks and our ecosystem within Databricks are rapidly changing. So naturally, the stuff we wrote a year ago might not run today. We are aware of this, and we have an official answer for you, which contains some really, really awesome news. So we are aware of this issue and are creating more manageable means of testing and ensuring that code examples are evergreen. We are developing a tool called Code Commons, and we are in the process of migrating and updating all of our demos, data camps, etc., onto this new tool. We will be sending out a general communication when things are ready. May still be another month or two, but we can try to push updates to the current location at the same time. Soon, maybe in the next week or so, you'll actually even see a tile in Portal for the Code Commons tool. We have made comments in the About page that all content is still under construction, but it's coming. So hopefully the old stuff is not too out of date, or maybe you can use Google or something to kind of pick up where things might have changed. But we are keeping a evergreen store of our material updated with Databricks and our own ecosystem. So be on the lookout for that. Okay, so what are our best practices for saving and navigating the workbench? The workbench here meaning the AWS S3 bucket that we are using kind of as a store of files to read and write things. We have actually a wealth of knowledge base articles on this. So in the notebook I sent out, there are a bunch of clickable links, including a knowledge base that I literally wrote to answer this exact question. So please feel free to also incorporate that into the answer in written form. Nonetheless, I will talk about it in detail here. So basically, your workflow is probably going to have 3 or 4 of these 4 steps. You are going to upload a file to the workbench via probably UFM, the Unified File Management, I think it stands for. It's the graphical interface where you can like upload files. We are going to mount the workbench onto your Databricks instances file system. More on that in a second. And then you can read and write to this location as much as you want. And then before you are done working for the day, please unmount this workbench. And I'll tell you why we have to do that as well. Okay, so how do we do these things? Step 1 is via a GUI. I'm not going to go over that because I don't want to like show you things you may or may not have access to. But if you have access to UFM, it's not so difficult. It's mostly click and drag. I think there's like an upload button. So upload to the UFM in a place where you are allowed to do it, and your sort of directorate says you should be doing these things. And then step 2 is to mount. So mounting a file system is basically taking a location and putting it onto another file system where it can be accessed as if it was part of that native file system. So the way we can do that is with dbutils fs mount. And I'm going to take the source location, which is the S3 bucket. Yes, that is what the S3 bucket looks like. It's a bunch of random numbers. So it's the 714 blah, 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 CDR, Lakehouse, object store, prod. And I'm going to mount a like example data location. And you are going to mount it onto /MNT, which is where we have designated places to mount things. And you're going to give it a unique name. So just for this one, I named it QA demo. These mounts persist after you exit Databricks, so please make sure to pick a name that hasn't already been picked, is unique, and other people aren't going to kind of like, accidentally use it or write over it or something. I think you'd actually get an error if you tried to write over it. But anyway, please make sure to pick one. Let's see if this notebook is live. I hope it is. This might take like a good couple seconds here. So while the file system is mounting, I want to talk about how you can actually navigate it. I know that it is kind of a pain in the butt that there is no way to just like kind of click through the folders, but kind of there is because you can just have UFM open and clicking around and things like that. But there is, if you're used to this, a command line-ish sort of set of commands. So dbutils fsls. ls mirrors the command line command ls for listing files in a location. So I have mounted this location onto /mnt/qa demo. So if I ls that folder, you can see all of the files and folders in here. This is using the dbutils library that's automatically read into Python when you create a new Python notebook. But this can also be done via these magics or macros. I think people call them like magics, but they're macros, right? There's the fs macro for ls. Like anything that's in dbutils also exists with this syntax. And it does have to be the first line of the cell. So fs, ls, the same location, you get kind of the same output. Maybe it's a little bit prettier. I don't know why this is taking more than 1 second. Yeah, so there it is. And this is maybe a little bit prettier, but for some reason it took 7 seconds. I don't know why. And then step 3 is, well, actually, I guess you might not be satisfied with that answer. You can keep clicking around in here, right? So you can't click this, but you can see in here, there's a folder called, actually, what am I going to use in this next step? SM housing test CSV. So there's a folder in here called SM housing test. I can, again, look one file deeper to see what's in there. And now in SM housing test, there are 4 additional folders, I think. Yeah, folders. And you can tell they're folders because they end with a slash. Okay. And then here's where you want to do your stuff. You want to be able to read and write from this location, right? So you can Spark read. In this case, they're CSVs. MNT QA demo, housing test, CSV. Remember, distributed data is actually stored in a file, or sorry, in a folder, and in that folder are all of the different chunks of the data. So even though it is a folder, it is a data set. So we read it. You can, show the first 5 rows. Very, very nice. There it is, the first 5 rows of this sample data set. And then you go about your work, right? You read more data sets in, do some joins, maybe write some stuff back out to the workbench. And then at the end of your workflow, you are required by the rules, not by Databricks, by us, to unmount this mount. So remember, these mounts persist after you log off. So we don't want to just kind of like clog up this mount space. So it is a best practice to tidy your workspace and now unmount. Nothing's being deleted here. It's just the connection between these 2 file systems is being removed. So please, please, please unmount. More details about this whole process and a little bit of a deeper dive into it is explored in the knowledge base article that is linked up above. All right, please unmount. I assume this is going to work. I'm going to go on to the next question. All right, cool. Make sure you do get this output to verify that it did work in case you have a typo. Okay. Are there any built-in references for zip codes, counties, and states, and other things like cities? Kind of no. So Python doesn't have anything, but there are many, many third-party libraries out there for this. Notably, our friends at the Census. There's a Census Bureau API built and maintained by the US Census Bureau that anybody in the world can use. It does require an API key. There is also a US library, which looks very minimal and probably not data frame friendly, so maybe you'd be less interested in that. Probably be more interested in Census. But the real answer is you probably don't want to use either of these because we have built one for you. So in our public data zip codes table, our team members actually have a built and periodically updated and maintained, because these things actually do change every once in a while, folder of these references. So because that zip codes and things do change very, very, I think rarely, but like it does happen. It could be that when you run the same code, you might get different answers if you run it month to month. So if you don't want real-time updates, it might be better for you to save your own version of this table for your own use later. But I wouldn't really anticipate any breaking changes. All right, where is it? So it is public data.zip codes. Here's the first 5 rows. There we go. Okay. Why are these taking so long? 12 seconds. So in here we have zip code, type of zip code, whether or not it's been decommissioned, the primary city in that zip code, acceptable cities. I'm not really sure what this means, but thankfully I don't have to. Unacceptable cities. I don't know what they did. State, county, time zone, area codes, country, latitude, longitude, and so on. Depending on what you need this for, I think everything you could possibly need is in here. For example, if you just want a county reference for what counties are in each state, you can just do a select distinct, right? So here's a select distinct of every state and county in the country. You'll notice that I don't know if these are errors or just weird anomalies or they're on purpose, but there are actually like blanks in here. So there are, a blank county in a state. I don't really know why, but you might have to do some additional data cleaning. But here, so here's a county reference if you're interested. A zip code reference for every zip code and state combination in the country.
Tim, just to share with everybody, this data source is actually from USPS themselves, so this is
Cool.
what they have.
Thank you for that. I did not know. And that means it's got to be correct. Okay. Now for a more complicated question. Many of you have asked about Windows functions in PySpark. So they exist in PySpark and can be done actually via 2 separate methods you might be happy to know. You can just use SQL. So if you are familiar with SQL, technically you don't really need to learn anything in PySpark because remember, you can always just carry out a SQL query in PySpark. So of course there's window functions because there's window functions in SQL. But of course, PySpark does have a built-in window syntax, which I actually kind of really like. I'll be honest, I did not know too much about this syntax until researching the answer to this question. And the more I looked into it, the more I think that it's actually pretty clean. So there are some additional notes I want to talk about, and that is that Windows functions are what we call wide transformations, which means that in order to carry them out, it actually requires that data is reshuffled across worker nodes, which in PySpark is generally something you want to avoid. For example, sorting a data set is also considered a wide transformation because in order to sort distributed data, data needs to travel between the worker nodes, which is something that can really slow down large calculations. So if you don't need to do a window function, don't. If you do need to do a window function, try to do it after you've aggregated the data so the data set is smaller. And if you do need to do a window function on a large data set anyway, get a cup of coffee ready or go make coffee while it's running because it might take a little bit longer. Also, I got pretty annoyed doing research for this because the word partition is used in a couple different ways in the Spark ecosystem. So a partition is a logical grouping used by window functions. So if you're familiar with SQL, you have this like partition by syntax, which is kind of like a group by. But also, a partition is the physical data distribution on the Spark cluster. So if you have 32 worker nodes, and then each worker node has 2 executors on each node, you might have 64 partitions. The partition that is a window function partition and the partition that is your PySpark partition are not the same thing. They could be the same thing. You could actually deliberately change it so that they do distribute that way over the nodes. By default, that is not the case. Annoyingly, they're both called partitions. So just probably won't mess you up at all, but I was kind of annoyed by that. All right, I also included some additional resources here, including an office hours topic we have had in the past that goes over window functions in SQL. And we also have another resource about replicating Sas functionalities using Spark Windows. Yeah, window functions. Okay, so what does this look like? I do have an example set up for us. So I have some revenue data. This is fake data I made for our previous session. There we go. So this data set is over time. We have revenue for each department. There are 4 total departments in this data set, and the data set spans calendar year 2025. So I might like to calculate something like, what is the average daily revenue by department? That could be used as a window function. Or maybe I want to calculate the rolling mean. So the 5-day rolling average of revenue within each department, not within each department. Or I guess I probably shouldn't do that, but within each department. So if you're familiar with SQL, good news, you can just do this. So here I define a string. In Python, if you want to define a multi-line string, you have to use these triple quotes. So here's my query. Select these rows, and then also the average of revenue over partition by department, order by the date, rows between 4 preceding and the current row. So this is how you calculate a 5-day moving average in SQL. I know it's super verbose. I had to look it up. I don't have anything like this memorized, but basically what I'm doing is I'm saying, okay, take the date and use that as the ordering variable, right? Like order over time. And then partition by department ID. So whatever I'm going to do with this calculation, do it within each department, because there are 4 in my data set, numbered 1 through 4. And then take the average over the current row up to 4 rows back. So this row and the 4 previous rows make up 5 days. And I called that the revenue rolling mean. I also calculate another one. So take the average revenue over and then just partition by department ID. So this is calculating the average revenue within each department. This sounds like a group by, but the difference is a group by will aggregate your data set. It'll be down to 4 rows, 1 for every department, and I'll have the average. The partition by will calculate it, but then broadcast it over each row. So I'll show you what that means. To just go ahead and calculate run a SQL query, you just say SQL, and then the query that goes in here. So here is my revenue window data. And here it is. So for department 1, we have each day's rolling average. This isn't so interesting for the rolling mean because there aren't 5 days yet. But the revenue mean by department is going to be the same for every department ID 1, because that's what I did. Okay, so that's how you do this in SQL, but if you knew SQL, you already knew how to do that. The trick here is to realize that you can just do whatever SQL code you want to get a calculation. Oh, sorry, I'm missing some chat here. The windowing, partitioning with spaces. A long time ago, subsetting claims data. Okay. So this command in cell 15 uses straight SQL, no PySpark. Sort of. So it all uses Spark. So Spark is the underlying technology that executes what is effectively SQL across many nodes. So when we do SQL queries, like I did up above, that is technically using Spark in the backend, I believe. PySpark actually allows you to write Python code that translates into Spark code. So for every query you can do, you can actually go back and recover, or rather, for every PySpark command you do, you can go back and recover the SQL query. So it's all being translated into the same underlying technology. So the answer is it's using Spark. The command down here is using PySpark, and this is written in the native Spark dialect. That is, I hope I'm not like going down another rabbit hole, but the answer to your question is it is SQL. But technically, all of the PySpark code is also SQL. I'll show you what I mean by this maybe in the next cell. So here is that exact same query using the PySpark syntax. So from PySpark SQL window, I imported window, that's with a big W there. And I also imported SQL functions as F. This is a pretty normal way to do it. So what I did is I defined these windows in advance. So I defined window 1 to be a window partitioned by the department ID and then ordered by the date. And I defined another window to be partitioned by just the department ID. And then I use regular old PySpark syntax to just create new columns, right? So this is how you create a new column in PySpark. I'm calling it revenue rolling mean like I did above, and it's going to be the average of revenue over this window that I defined up above. Same thing with this one. And I can run this, and I will get the exact same data set up above. This rev window, I think I can say show query. Is that the name of it? Display query. Oop. Let me see if I can do a quick Google to show this off to you. Not explain, that's not what I want. Maybe it is explain. I think this is going to show me the calculation. Yeah, that's not what I want.
I think you're thinking of the sparkly R function.
It exists in PySpark.
Oh, okay.
Maybe if somebody else knows it, they can tell me. Nah, sorry. But there is a way, given this, you can actually show the query that was executed under the hood to get the query back. But maybe this is actually related to the next question. So the .explain method actually shows the execution tree that occurs when you will run this code. So this is very difficult to understand because it's not really understandable. But this is what is happening using the underlying Spark commands when you run this. You're going to run columnar to row, photon result stage, photon window, and then it says of these columns, and we're getting so deep in here that this is not really human readable. Like I can't understand what's going on here, but maybe a more experienced Spark programmer might be able to. But yeah, photon exploitation, the query is fully supported by Photon. Great, thank you. Okay.
I think we discussed some of that in office hour 5 and 6, I think, with the Python introduction to PySpark and such. So it's in an office hour content as well.
Cool. 5 and 6. I didn't link those. If Dan, if you have them handy, would you like to share with the chat? Or maybe
I will get.
Okay. And the final question that was asked of us is a little bit of a tricky one. Basically, somebody just said, tell me more about the Spark UI. Well, we did just have a full office hour and I think a lunch and learn pretty recently on the Spark UI, how to open it up, how to read it, how to look at different things. I've included the notebook and recordings for those sessions. Please feel free to view those on your own, but I will also talk about it a little bit. Dan, I saw you came off mute. Maybe by accident.
Not intentional, but I did put it in there.
Awesome. Thank you so much. Okay, so what is this? The Spark UI is an area where you can visibly see your Spark jobs, processes, and statuses. You can peruse the GUI to see the actual behind-the-scenes implementation of a Spark computation and any associated errors. You can actually view it in real time too. You don't have to wait until your query has finished running. You can watch it probably maybe fail in real time, right? You can see what's going on or what's taking so long also, if it's taking a really long time. So some notes on failed stages and also skipped stages. So note that skipped stages are not failed stages. Sometimes the behind the scenes optimization that Spark does, it will realize that a stage can actually be skipped because it is canceled out by a previous step or something like that. For example, if you sort a data set twice, you could probably skip the second sort because it's already been sorted, right? So it will intelligently skip stages that just don't need to be executed, which is an interesting fact I think a lot of people don't realize about Spark. Spark can actually reorder your commands to better optimize your code. So if you need to do a sort and a filter, it is always better to filter first, then sort. So if you sort, then filter, Spark will say, oh no, it's better if we do it the other way, and will actually rearrange the calculation for you to be better and guarantee the same results. So sometimes stages can be skipped, sometimes they can be rearranged, but sometimes also they fail. So if you have, 2 steps and the first one fails, I believe the second one will show up as skipped. Even though it didn't really get skipped, it's just that it never got there, right? And failed stages can occur a couple ways. One is with a code error. So if the code you wrote results in an error, then this is going to result in a fail stage. Or a cluster error. If you don't have enough memory or processing allocated, a stage can fail. This can happen if your data is too big for the cluster you've allotted to it, or your calculation is too complicated and takes up way more processing power than you have allocated. This will result in a failed stage, and you might have to dig in a little deeper to maybe simplify your query or upgrade your resources to make the code stop. Remember, in our clusters, you might actually be sharing a cluster with one of your colleagues. One way to avoid this is by using a Spark job. When you create a Spark job, you're not sharing any processing with anybody. So if you find that your relatively simple queries and PySpark commands are failing, it might be because you're sharing with somebody else who's not maybe using their cluster as economically as you might be. So you can oftentimes or sometimes maybe optimize these by changing around your code or yeah. Should also be known that sometimes clusters just fail. It could be that your colleague is running a really big command or calculation and they take a whole cluster down and it's not even your fault. So sometimes these things can pop up and it just seems like out of nowhere. That'll happen rarely. It usually is your fault if something goes wrong, but could be somebody else or maybe even just random chance. Generally, these calculations are pretty resilient though, so it's pretty hard to just take a cluster down. All right, so how do I look at this? How do I actually see what's going on? So you can view Spark jobs. You can view Spark jobs by viewing the Spark user interface directly, or simply clicking on Spark jobs at the bottom of an executed cell. So Spark jobs can be viewed after the execution finishes or even live during the execution. This is useful for many reasons, but one such reason is to get a rough picture of how long your cell is going to take to run. So again, we have some resources here for you, but let me try to come up with an example to show you. And again, I will apologize in advance. Just because you can access these things doesn't mean they're so easy to read. So I have read in some data sets. If you were here for my SparklyR session, this is the same data, or for any of our previous interactive sessions, this is the data set of employees and departments. The data is not important, the command is. So what I'm going to do is I'm going to take my employees and I'm going to make a new column that is just their salary divided by 1,000. I'm going to join on the departments and I'm going to rename the department name. And then I'm going to sort by salary. So you can look at the results here. It's not interesting. What is interesting is right here, there's a button that says Spark Jobs. If this command was more complicated and was taking a lot more time, you would actually see a loading bar down here. And you can actually visibly see your command run in real time. You can kind of guess maybe how long it's going to take. But you'll oftentimes see a couple jobs here, usually 2, I think, is a minimum. So this one is stage 2. I think this one is going to end up being the bulk of this query because it's a little bit bigger. So let's see it. So you can click open here. We have skipped stages, and then we have 2 more stages that succeeded. So let's just view the whole job. So I'm going to click view. And it brings up a window here, and we see a lot. The status of the job is succeeded, when it occurred, how long it took, associated SQL query. I think you can actually look at this. I'm not going to click it because I don't want to lose where I am. Job group, I think this is just an identifier. Completed stages and skipped stages. And there is a DAG visualization. This is a directed acyclic graph. So under the hood of Spark, what is really going on is it's setting up basically a graph of calculations. And it says once one calculation is done, it lets the next node in the graph know so it can do its calculations. And I did this one on purpose because you can see the merge, right? I merged two data frames. You can actually see where that happens, even if you can't read it. So if I click this, or I'm going to mouse over it, it is a photon file scan. I think this is reading in the data set. Map partitions. This might also be a map partitions. Shuffled block. I think this is creating, I think this block might create the salary 1000 column. And then I merge. And this is a Cartesian RDD, resilient distributed data frame. This is the join. You can actually visibly see that. It seems we don't have permissions to view the DAGs. That is news to me. You should be able to. If you don't, I'm sorry, I don't have the power to make it so. But you can see everything here. Even if you can't see the DAG, you should, well, actually, maybe not if you can't see the DAG. But if you had the ability, you should also be able to see the stages themselves, whether or not they failed, and oftentimes an error if there is an error. So that's way more interesting. So let's cause problems for no reason. So in the next cell, or last cell of the day, I have created a problem. This was actually harder to do on purpose than it sounds. I tried to create all kinds of errors like dividing by 0 and casting a string as an integer or something like that. And it just creates nulls instead of creating an error. So I finally asked ChatGPT, is like, how do I actually cause a dang problem? And it gave me this idea to just cause one on purpose with the raise command. If you've never used the raise command in Python, well, that's pretty normal. The raise command is how you just say there's an error here. So I'm going to raise a value error anytime this function encounters an x. So it's a function that inputs x. If x is 2, raise an error. Otherwise, return x. And I'm going to create a UDF of this function so that it can be distributed across our Spark nodes. And then I am going to use it. So I'm going to run this, and of course I'm going to get an error. And I think the error output that you actually get after the cell is pretty informative, but not always. Let's see. An exception was thrown from the Python worker. Please see the stack trace below. Column. Can I show more? How do I see more? There we go. Scroll, scroll, scroll. This is all gibberish. I can't read this. And there is actually no helpful error here, is there? Oh no, here it is, value error. Intentional error for value 2. It is actually pretty normal for Spark errors to just be totally unhelpful, because one side effect of this beautiful software that makes your code run really fast is that all of the errors are going to happen really far away from you, right? You have your main node and all of your worker nodes, and these worker nodes are the ones encountering errors, but that's not the computer you're on. So sometimes it can actually be really hard to find these error messages. I think Spark's getting a lot better at this, and this one wasn't so complicated, so it was kind of right here front and center. But if you want to dig in, how do you find that error across your worker nodes? So I'm going to open the Spark job panel again, and here it is, job 32, 0 out of 0, 1 skipped, so it failed. Right, 0 out of 1 succeeded. Let's look at it. So here it is. Here's what would have happened. Failed stages. And we have, this was stage 53 that failed. Yep, that checks out. It's always important to look at the IDs here. That can actually help you pinpoint exactly where things went wrong. And there are Java and Scala errors here, which are hard for anybody to read. Some things here, 0 out of 1, some failures. And here's the failure reason. Job aborted due to stage failure. Task 0 in stage 53 failed 4 times. How did it fail 4 times? It failed 4 times because I have 4 nodes. right? So it distributed my data across these 4 nodes, and each of those 4 nodes encountered an error. So that's why you might see one error happened many times. 0.3 stages, 53, a bunch of stuff here. And if you click details here, you can see the full error message. Here it is, value error, intentional error for value 2. Was this easy to find? No, I'm sorry. But this is how kind of deep you have to go to diagnose some really, really tricky errors. All right, I do see a screenshot came in. Is that? You do not have permissions to view this. Oh, I'm so sorry. That's kind of a pain. That will make things harder to debug. So yeah, reach out to the help desk as Dan said. Thank you for that. Okay, I hope this was super helpful. Like I said, this is not really a live Q&A, but I am acknowledging the chat if there are add-on questions to the things we've talked about. So I will kind of, stall for time a little bit because we're ending a little early, and I want to know if there are more questions in the chat. As we are concluding here, please, please, please fill out that survey you are going to get momentarily. It's literally just going to be a pop-up window on your Zoom screen. There's a text box for you to write your own questions. We will be doing these Q&A sessions periodically, and I'm not really good at singing and dancing, so I'd rather have your questions to answer on these calls. So please give us those. We'll also send out the same survey at the end of every office hour, data camp, things like that. And like I said before, be mindful about the questions you ask. Make sure you're giving enough detail so that I can solve them and know what you're asking. And also, please be mindful that I might not have access to every single data set, and questions about your specific data problems I also might not be able to talk about live with other people who don't have the same permissions as you. But other than that, I'd love to hear kind of what's giving you woes about the Databricks environment so we can all get better at this. I learned a lot making this.
Tim, are you okay if I administer that survey at this point?
Yes, please. Thank you so much.
Okay, cool. Okay, so as Tim said, it will just pop up on your screen. Please make sure that you are scrolling the whole way down to make sure that you don't miss any questions. And then that last question is that one where you can give us additional feedback and any questions that you have that you would like answered. And then as soon as you're done, you can feel free to drop. Thank you so much for joining us today. And thank you so much to Tim for presenting. Gosh, sorry. It feels like the Mondayest Tuesday ever. Thank you, everyone.
Thanks, everyone. Bye.